Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. So last time we took a look at a little bit of an optimization of how we could basically make our renderer 2D, our 2D renderer, a lot simpler in the sense that we added kind of one shader for everything. Make sure that you guys check out that video if you haven't already, because it's a cool little optimization and it's a different kind of way of thinking. I think that video is quite good. Now today, we're going to be talking about what we said we would last time, which was basically taking a little bit of a look at performance and timing and benchmarking and profiling. There's a lot of these kind of buzzwords floating around here. What we're going to do today is I'm kind of probably going to introduce this like as an introduction today, because this is going to end up being like a 2 or 3 part mini series within, I guess, this game engine series, where we're just basically going to talk about you know, how we can both change our code, I guess, modify our code in a way that allows us to record certain metrics, such as CPU usage, CPU time, basically. And then also how to kind of, I guess, look at and analyze that data in a meaningful way. Because, you know, in this kind of topic, there's two sides, right? There's two sides of the coin. There's the actual collecting data, right? So you need to figure out what data you want, what numbers are going to be useful to you. You know, for example, we might want to know how long one frame takes, how long the kind of updating of the camera takes, how long clearing the renderer takes, even maybe you want to, if you want to kind of drill down into specific renderer commands. You want to kind of like lay this out and be like, okay, when I hit the mouse button, when I render I am GUI, or everything that happens in my game engine, in my game, I would like to know how long everything takes. So that way, if, you know, if everything's kind of taking 1 millisecond and then there's this one function that every frame is taking 5 milliseconds, I know that, okay, maybe I should optimize that specific area of code. If you're kind of flying blind in a way where you just don't know like what is slow, what is fast, you kind of look at your frame and your frame rate is just like 20 or something and it's just not performing well, it can be difficult to drill down and actually figure out what's wrong. So that's kind of the sense that, okay, well, I want to know how long every function takes, for example, right? I want to know this onUpdate, this sandbox 2D onUpdate function that we have here, how many milliseconds every frame am I spending inside that function doing that function, right? How much time is my renderer spending actually rendering these quads? You know, do I need to speed that up? And of course, that's going to be important because when we do move on to optimizing our renderer 2D, because it is a very simple kind of 1 quad per draw style 2D renderer at this point, when we do optimize it, it's going to be really nice to see that massive performance benefit that we do get. And that's why I want to get all this kind of timing profiling stuff done. Now, the other side of that coin, the other side of this profiling problem that I think people don't realize as often is, once I have that data, what am I going to do with it? Okay, cool, 3 milliseconds here, right? Do I really want like a list of numbers that just tells me that, okay, this took 5 milliseconds, this took 3 milliseconds, this took 0.5, this took 0.3, okay, cool, how does this work? That's probably not a very good way of doing it. I want to actually visualize this data somehow. Apart from just maybe seeing it visually to begin with, I also want to maybe record specific trends in the data or whatever. You know, for example, what happens if 10 frames are fine, but then every 10th frame or something, or every 50th frame, there's a bit of a hitch. Why does that happen? I want to kind of draw attention to that, weed that out, because that might be information that's useful to me. And then of course, yeah, visualizing the data would be incredible as well. So all of these things are things that we're going to cover in this little mini series. We're going to basically just, I don't want to spend too long on this. And I am actually planning to make a standalone video specifically about like profiling and benchmarking. In fact, I do have a video on benchmarking in C++. Definitely check that out because I'm actually going to be using some of the code from that video here today. But basically, I don't want to spend too long on this. So today we're just going to like see if we can get some numbers out. And then next week, next episode, we're going to see if we can visualize those numbers somehow. I do want to point out as well that this is going to be completely independent of any kind of tooling, right? I don't want to tie this to Visual Studio, for example. Now, this is another little discussion. There are profiling tools available. Every IDE probably has a profiler built in, and then aside from that, there's obviously standalone profilers, which will basically can look at your code and be like, okay, well, this is how long every function takes. That's something that Visual Studio does offer, and I might cover that in a different video, probably part of the C++ series or something like that. just a standalone video. It's good. I won't lie. The profiling tools in Visual Studio are not bad at all, but it's better to, ultimately, it's better to, not necessarily better, but like, for example, I would still use Visual Studio's profiling tools, even if I had my own. But in a lot of cases, it makes a lot of sense to write your own profiling tools. The reason is that it's gonna be something that is inside your code base. And because of that, you know, presumably, you kind of distance yourself. It's not kind of part of the development environment you choose to work in, right? It's part of your actual code library. It's part of your actual engine. That's really useful because suddenly that means that I don't need to be using Visual Studio. I don't need to have Visual Studio hooked into my code to see how fast things take, right? That's not good. What if I'm deploying on Mac? Well, I can use Xcode and that has some like instrumentation tools, great. What about Linux? You know, I'll have to use a different profile on that. What about Android? What about iOS? What about consoles? You know, you start ending up with all of this kind of situation here where it's like, you know, I'm using a different tool for every platform, and not only that, but I have to have like a debugger connected, or I have to have like this profiling tool connected to my app to actually see how fast everything is. What if just randomly on a special build, we'll say, of my code when I'm running on some user's machine, for example, right? They've downloaded my game, I've let my friend play my game. It's running really slowly on his computer. I don't understand why, because he's got a great graphics card or whatever, right? I want to see what's going on. Well, wouldn't it be nice to just flip on a switch, get all that data out, analyze it, be able to look at it and see what's wrong without having to be like, okay, well, first you're going to have to download Visual Studio and then we're going to have to... We don't want that, right? This might have been a long-winded explanation, but my point is it's really nice to have your own tools. And by doing that, you know, we can easily kind of take a look at every function in our code. It's called instrumentation when we actually go through our code and we add additional code basically that will track all of these things. This is definitely something that you want to shut off for distribution builds. It's usually just used for debug builds or release builds. It usually has its own flag as well because you don't want it to be running all the time or being compiled into your code all the time. So anyway, there's a lot of things we can talk about. I don't want to, again, I don't want to make this huge. Let's just dive in. We're going to take a timer class from the benchmarking in C++ code, benchmarking in C++ video that I had linked up there that I made a while ago. We're going to take that timer class, we're going to change it around a little bit, and then we're going to see if we can record some basic metrics from within Sandbox 2D to begin with. And you know what else? I want to give a huge thank you to all the patrons that made this series possible. Patreon.com/the Cherno. Series will not be here without you guys. I've done some pretty exciting things. Lately, I've had an exclusive video about talking about how I'm getting Vulkan into Hazel. And also, of course, there is a Hazel development branch. It's becoming... What I want to do with Patreon, and what I want to do with those exclusive videos is kind of treat them as like a weekly devlog, right? Not like the one that went up on YouTube where it's all like fancy, there's all like these cinematic like shots and everything, and it's like it took me like a week to edit. I don't want anything like that. Just a quick and dirty video, pretty much live, just like a live stream almost. About me just kind of being like, okay, well, this is what I did with Hazel this week, or this is what I did with, you know, my channel this week or whatever. Like a little devlog. Because me working by myself as a full-time YouTuber, it's a little bit difficult to stay accountable to all of these things that I'm working on. So I think that if I was to make a weekly video, if I forced myself every Monday morning or every Friday, because it's like the end of the week, to just kind of make a video where I'm like, this is what I did all week and show off a bunch of things, I think that would probably be very healthy for me and it'd be cool for you guys to see as well. So that's kind of the plan. I guess I should probably do the first of these videos like tomorrow, because tomorrow's Friday. We'll see. But anyway, so that's what's going on. And of course, thank you so much for helping to support my channel. Let's get into this profiling stuff. Okay, so this is what we had at the moment. Again, you know, we did this last episode. It's not really worth talking too much about it here. I want to see how long everything takes. That's kind of the goal for today. I'm just going to scroll up to the very top of this file. This is the sandbox2d.cpp file. We're going to be like real quick and dirty here because I just want to show you guys how this works. I'm going to paste in a basic timer class. This is basically the same thing that was in the benchmarking C++ video. I changed it a little bit. We're taking in a const char pointer as the name here. and we're doing some other loose stuff, but basically it's really simple, right? What we do is it's kind of scope based. It's RAII, which basically just means that when we construct it, it starts up, and when we destroy it, it stops, right? And in fact, this is annoying me slightly. I'm just going to move the destructor over here. So basically, all it's doing, again, is it's starting the timer when we actually construct the object, and when we destroy the object, if it hasn't already been stopped, it will record the end time point, and then calculate the distance between, the difference between the two to get our duration in milliseconds, which we should probably also write. Okay, cool. So you might have a few questions about this. Again, this is just an example piece of code. One of the questions might be why are we using const char pointers? This is not C or C++. Yes, it is, but I don't want to store an entire like heap allocated string or anything like that, because this is meant to be a static string. And you know, we can talk about strings in a future episode, but basically, if you have a static string, static meaning that it's literally typed in like this, it's not like a variable, it's not mutable at all, it's something that's literally written in the code as a static string, then you do not want to use std string. Because by doing so, you know, you're basically, apart from the potential heap allocation and all of that, there's so much unnecessary overhead, because it really, you know, what is a string? It's just a bunch of characters. It's a memory address that we have with a buffer that has a bunch of characters. That's all I need it for, because it's going to be a static string. Okay, cool. So that's out of the way. Let's talk about how we can use this. Well, at the moment, all it does is it outputs this to the console. Now that's great. Let's see it in action quickly. I'm just going to grab this timer. And we probably need to include chrono as well. If we go over here into on update, that's a good candidate for this. I'll type in timer. We'll have to give it a name. I'll give it the name of this function. So sandbox 2D on update. So this is what I mean by static string, right? This is never going to be something that we like take in from a file or gets generated in any way through our program code. Just a static string. And that should be it. Like if I just run this program now, theoretically we should know how long this on update function takes. Because what are we doing? We're printing it to the console. Now, we get a value that's between 0 and 1. I mean, sometimes it's 0, sometimes it's 1, most of the time it's 0. The reason that this is happening, of course, is because you know, we're treating this as milliseconds. We've told our timer we want milliseconds, so it's giving us to the closest millisecond. We'll change this to microseconds to make this a little bit more clear, and then I'll probably just do auto, you know, duration equals, so we had n minus start. I'm actually going to make this a float. N minus start, and then I'll multiply it by 0.001 just to get that from microseconds into milliseconds. So now that we have this, we can replace that with that, and we should get something a little bit more precise here. All right, and here we go to 3 decimal places. We seem to be getting a pretty accurate timing here of how long our update cycle actually takes. So specifically the user-based update cycle, meaning the actual client code on update function. Okay, brilliant. So we've got that, that's fantastic. Now, having that data in the console is a little bit, well, not very useful because we have to look at the console. Also, if we have numerous ones of these, for example, we have sandbox 2D on update, and we should probably actually log like the name or something like that instead of just, you know, a function. Instead of just duration as a static string. But anyway, if I want to see, for example, this is scope-based, remember, right? So if I want to see, for example, you know, camera on update, and instead of actually putting it into the camera controller function, we're going to put it here. If I want to see something like this, and I probably don't even have to rename this, I can just, you know, we'll do camera controller on update. You know, it's not bad. Like, I'm going to see all the data here, but I'm just kind of trying to demonstrate to you guys why it's not great. This is clearly a mess, right? I'd much rather see it like in IMGUI, and eventually maybe in some kind of visual way. So how do we do that? Well, I'm going to kind of quickly add something to this that's going to actually make it so that we can visualize this. Not really visualize this, but see this in IMGUI inside like an actual control. I'll make a little struct called profile result. This is going to basically contain a const char name, and then we'll also have the actual time. So this kind of profile result, I'll just make a vector of these so that we can have basically unlimited amounts of these kind of profile results, we'll say. And then what I want to do is I want to actually kind of, I guess, push back into that vector when I actually get a profile result. And then maybe over here, I'll have some kind of section where I just go through all of the profile results. So result in profile results. And then what we'll do in some form or another, we'll just present this into IMGUI. So I'll just use IMGUI text, which is like a formatted text option. And then maybe I can do something like the name of the result, and then eventually like the result. So in fact, if we were to do this, we'd need to concatenate the two strings. So maybe let's just make like a, I'll call this label, little buffer here, so that we can use, because we have to use C functions. We don't have to use C functions. Again, you could convert this into a standard string and do everything there, but I'm trying to be a little bit more mindful of performance, I guess, and we can just do this all in the stack really easily by just doing this. So label is our destination, source. I guess we'll put the name of the profile result, and then into label we'll also concatenate the so what does this label have to be? Okay, it's a formatted label. So in other words, we'll have the name, right, which is already in there, and then we'll have two spaces and then percentage 0.2f and then ms for milliseconds. So this should give us the time. I guess I'll do 0.3 for more precision. That'll give us the time in milliseconds. So now we can do label and then result.time. Okay, so we're just basically, this is just the same as printf. We're formatting, we're basically formatting our label here so that it not only contains the name, but then followed by the name, following the name, it has our time to 3 decimal places. Okay, cool. So we've got that, pretty simple. Now we have to have some way of actually, I guess, putting this back into here. Now, we could do some crazy things here. I mean, I'll probably have to modify the timer class. I'll make it a little bit better, I think. I'll make it a little bit more universal. What I'll do instead of this is I'll actually pass in a Lambda, which will return a profile result. And then this profile result, so I can probably just use auto here. This profile result, I'll then be able to do something like profile results.pushback and then profile result. Okay, so I'll basically just have something like this, and we'll take this by reference, of course. So we have profile results, pushback, profile result, so that'll actually get it in there, and then obviously as soon as I render them, I want to clear them. So we'll just do clear here. Okay. Sounds good to me. Obviously we need to extend the API to include this, and then yeah, should be good. So what I'll do is I'll add, now I could take in an std function here. That will probably might cause a heap allocation. It's slightly better in this case, and this is going to be a throwaway timer anyway, obviously. So it's quite nice in this case to actually use this Lambda without having to construct an std function object. And because a Lambda will actually generate a type that is basically unique to this Lambda, there's no way for us to capture that really. So we have to use something like templates or auto to actually handle it. So what I'll do is I'll just use our template here. So this will be like our function. I'll call it func. I'm just taking it in as a double reference here, and then I'm going to, well, we'll copy it into this class. So we'll just have mfunc like that, and it'll just be fn here, which is like this is essentially going to be the type of Lambda that it is, right? And it can be any Lambda. That's why we're making this a template. And then what we'll do is we'll set up mfunc, like we'll set the member variable here. I'll put it directly under name. And then instead of us doing this, all I'm going to do is call back that callback, right? It's just going to be Lambda that we're calling, and we're going to call it with name, so mname, and then duration, okay? So that's it, really. So what this will do is when the timer stops, we're going to call this callback function, which is our Lambda, right? And that's going to, well, we're constructing a profile result with name and duration. And then what that's going to do is just go into mProfile results and push back that profile result. So now we should have that list there. And that's it. And realistically, like you'd need to copy this everywhere. That's going to get annoying. So I'm just going to make a macro, define, you know, profile scope, I guess, because this is a scope profile. We'll do timer. We'll probably make it unique with a line number just in case. you want to do two in a row, whatever, because otherwise, you know, that won't work, for example, because they're called the same thing. Whereas by using line, we're concatenating the line number, which is just going to give us like the line number. So it'll give us the unique name, is the whole point of this thing. And then we'll need to take in the name, which I guess, yeah, we'll just take in the name, and then we'll construct this lambda, which just basically pushes back our profile result. That's it, I think, right? Cool. Okay, so now we can just use profile scope with the name, which is this. Pretty cool. So profile scope sandbox 2D on update, and then profile scope camera controller on update. We might as well change this around a little bit and make it so that we'll just add stuff basically. So we have like this, I don't know, render. I'll just say renderer prep. This is like the preparation for rendering, I guess. And then if we wanted to, you know, we'll also do the actual renderer draw, I guess, right? Which kind of does a begin scene and all of our draw quads. And we put these into scope, so the timer should stop automatically. Everything looks pretty good. And I don't know if this will work. Let's just see if I can get this to work first try. Well, we've got some errors, so that's great. So yeah, I did see a suspicious amount of curly brackets here, or rather not curly brackets, but parentheses. So yeah, I guess we don't need that extra one at the end. Yeah, let's hit F5. More errors. Okay, could not deduce template. So this is probably because we used auto here and it just can't deduce it. So whenever you get like, it's basically just a can't deduce auto error message. So this is a profile result. Let's tell it that. F5 once again. Okay, and we're running. Pretty cool. So if we, where's our window? Here it is. If we look at this window, check this out. So we have all four of our timings here, and they look pretty good. If we just click somewhere on the title bar to freeze this, you can see how long everything takes. So on update is 0.029 milliseconds, very fast. Then we have 0.013, 0.098, and then the actual, I guess the whole function. So the drawing takes about, you know, 0.1 millisecond, which is pretty quick. And then sandbox 2D on update takes, which is the entire function, altogether takes 0.145 milliseconds, which is very fast. Okay, cool. So one more thing I want to do, I'm regretting my decision here to have it in that order. I'm basically just going to flip this, and then this will be a string copy and then a string cat. This is basically just going to make it so that our time is first, followed by the name. That way it'll just be nicely aligned, unlike that mess that we saw before. Okay, that is better. And this, we should probably get rid of this Dear I Am GUI demo window. In fact, that's annoying me so much. Is that inside I Am GUI layer or somewhere? It probably is. Yeah, show demo window on I Am GUI render. We don't need that on I Am GUI render at all, I think. I'll just get rid of that entire function. Because that I Am GUI layer shouldn't be doing any I Am GUI rendering, most likely. You know, even core stuff should probably be coming from the renderer or somewhere. Okay, that's better. There we go. So that's that, right? We can see, oh, look, I made a full screen and I guess it took a bit more time. It's still very fast though. Anyway, this now shows us everything that we want to know about our profiles. It's pretty cool. You can stick this anywhere, right? Obviously this is not like the most ideal thing in the world. For example, if you have something that isn't per frame, like on event, it'd be pretty much impossible to track that. And then also, you know, this isn't like saving out anything. It's really kind of hard to inspect. It's a good rough way to just be like, okay, cool. You know, my sandbox drawing stuff is taking 0.215 milliseconds. I'm cool. That's great. And obviously if you add this profile, if you were to expand this and add the profile scope macros all around your code, like in every function, for example, so we added it into like renderer 2D begin scene, then draw quad and scene everywhere, then we would actually see everything. But having a long list of everything over here is not ideal either. So that's where the kind of visualization of data comes in, and ultimately what we'll talk about in the next episode. Hope you guys enjoyed this video. If you did, please hit that like button. As always, you can help support the series by going to patreon.com/Cherno, as I mentioned earlier in this video. Next time, we're going to talk about what we can do with this data now that we're actually collecting milliseconds and we've got this kind of timing code that's actually collecting data. What are we going to do with it? How are we going to visualize it? We're going to talk about that in the next video. I will see you guys later. Goodbye. bye.